welcome to this session on Java EE. Before I start, a few words about me. So my name is Delabassee, and despite my French accent, I'm not French. I live in Belgium, so I live just at the France border, in fact. So I work at Oracle in the Java organization. So the agenda for today is pretty easy. I will talk about Java EE 8. So I will basically give you an overview of what Java EE 8 will be about. Now, we have to keep in mind that it's really the early days of Java EE 8. I mean, everything has to go through the GCP and the different expert groups that are involved. So what I will say can change. I mean, in terms of APIs, in terms of features, and so on. So this is a mandatory Oracle slide that basically says that you shouldn't make any purchase decision based on what I will say today. It's pretty easy because there is no Java EE 8 application server to buy. So it's an advice that is very easy to follow. But anyway, just keep in mind, everything which I will say might change. So the current release of Java EE is Java EE 7. Java EE 7 was finalized 2 years ago, in June 2013. So we did quite a few things in Java EE 7. One of the team was HTML5. So if we look at the market for web proprietary UI, like Flash, Silverlight, and so on, they are basically being killed and replaced by HTML5. So we have to make sure that Java EE, which is a server-side platform, is able to deliver those kind of applications. So for example, we have introduced a WebSocket API to provide bidirectional full duplex communications to the platform. We have introduced a new JSON API, and so on. Something else, developer productivity. So if we look back in the Java EE days, in the G2E days, we have added a lot of capabilities and a lot of APIs to the platform. So the platform was very complete, but it was also complex to master. So around Java EE 5, we have started to look on how we can simplify the platform by using more annotations, by using convention over configuration, and so on. So the idea is really how we can make the platform more easy so that your life as a developer is easier. Something else, Java EE is at the end of the day an enterprise platform. So we have to make sure that we do provide the right capability for those types of applications. So in Java EE 7, we have introduced a new batch APIs to run batch jobs on top of the platform. There is a new concurrency API that allows you to use in a safe way some of the concurrent utility package from Java EC, and so on. So we were done with Java EE 7. So at that time, we had to start to look at what should we do next for Java EE. So we are looking at the market. I mean, we are seeing some obvious trends that might be, it might be a good idea to address them in the platform. We also have a lot of inputs coming from basically all the Java EE ecosystems. So we have discussion with the different Java EE licenses. So people like IBM, Red Hat, and so on. There are also a lot of discussion within the Java EE expert groups and the different expert groups that are developing specifications for the Java EE platforms. Each specs has also a JIRA, so you can field issue against a specification. So that's something that at some point in time will be considered. We're also doing BOF. Yesterday night we have a BOF. So during those BOF, when people complained about the platform, that's also something that we take internally and we discuss how we can address that over time. So at the end of the day, we had a lot of things that we wanted to do in the platform. So we had a long to-do list of good ideas that we would like to do in the platform. Now, when you have good ideas, it's sometimes useful to challenge those good ideas with a larger community. So, and also, if we want to do all that was on the list, I mean, we won't have Java EE 8 before the next 5-6 years, which is too far away. So we did a community survey where we basically put everything we wanted to do, and we have asked the community to provide feedback. Should we do that? If yes, what form should it take? If not, why? And we also had open questions where people had the ability to suggest things. So that's something that we did. This is the end result. I will not go into details. If you want to learn more about the survey, just go on glassfish.org/survey. But that survey gave us an input to start really to kickstart all the efforts around Java EE 8. So this is basically what I will talk about today. So we had 3 teams as of today for Java EE 8. The first one, HTML5 web tier enhancements. So basically continuing what we have started with Java EE 7. Ease of development, it's not a big surprise. We want to continue to simplify the platform as much as we can. And finally, infrastructure for running in the cloud. So the first one the first theme, and that's clearly the one for which, as of today, we have made the most progress. So I have more information to share on that one. So in that front, we plan to do different things. We'll have a new JSON binding API. We'll enhance the existing JSON-B API, which was added in Java 7. We'll introduce support for HTML5 SSE, server-sent event. We'll have a new action-based MVC framework. And last but not least, we will introduce support, HTTP2 support to the platform. So let's look at some of those. So the first one, so we'll have a new JSON binding API. So JSON-B is to JSON, so JSON-B is to JSON what JAX-B is to XML. So it's basically an API that allows you to marshal Java object to JSON document and the other way around. So unmarshal JSON document to Java object. Now, the thing is that we have on one side the Java object model, which is very rich. I mean, we have strings, in, float, and so on. Just look at dates, for example. We have many ways to represent a date. And on the other side, we have the JSON object model, which is very simple, very basic. We have strings, strings, numbers, Boolean, object, array, and possibly one or two, and that's it. So the API will basically provide a default behavior, how the marshalling should be done in one direction and how unmarshalling should be done in the other way around. And you will have the ability to customize that behavior. Now, if we look at the JSON-B space, I mean, it's already a pretty mature market. There are already a lot of solutions existing in that space. So we don't want to reinvent the wheel. As of today, we already have Jackson, JSON, Moxie, and so on. We don't want to introduce a new JSON-B framework. So the JSON-B API will really be an API that will sit on top of those binding frameworks. And at the end of the day, it will be up to those binding framework to provide the capability that will make you choose that solution versus another one. So if we look at some code, how the API looks like, again, this is the early days. I mean, it might change. So first, we need to have a JSON-B instance that we get through a JSON builder. So JSON builder create. So we would get a JSON-B instance from the default JSON builder from the default JSON-B provider. We might want to use another JSON-B framework. So that's how we would do it. So JSON-B provider, and then we specify which one we want to use. And then we still need to have that JSON-B instance. And then we would have those kind of method calls. So JSON-B from JSON, new file might book JSON, and then the object type that we expect to get. The other way around, so Java to JSON. So we again use the JSON-B instance, JSON-B to JSON, the Java object, and then where we want to send that. So continuing in the JSON space, what we would like to do in Java 8, we would like to enhance the JSON-B API. We plan to do different things on that front. So for example, we would like to adopt some of the new standards that are popping up in the JSON-B space. We would like to make the API more SE8 friendly, and so on. So sorry, I went too quickly. So the first standard that we will adopt is JSON pointer. So a JSON pointer is basically a standard syntax that allows you to reference a location within a JSON document. So you should think XPath, basically, but for JSON. So this is an example of that syntax. So if we look at an example how it works, so we have a JSON array, so we have a Java object, and that would be the JSON representation of the Java object. So we first need to define the pointer. So new JSON pointer, then we specify that syntax. So basically here I'm talking about the object at index 0, so the first one, and then the key value whose key is name, so that guy. So I have my pointer, now I can do something. Get value, for example, is one of the things I can do. So what I would get in return, I would get Duke. So in terms of methods, we can do a get value, but we also have a few JSON operations. Add, replace, remove. So this is an example for a replace operation. So we set the pointer, then on the pointer we set a replace, that's the JSON document the JSON object, sorry, that we want to use, and that's the new value that we want to replace. And we have to keep in mind that the JSON API is immutable. So what we will get in return is a new JSON array. So the original one will not be touched. Another standard that we will adopt is JSON patch. It's based on a JSON pointer. And a JSON patch is basically a JSON document that describes the set of operations that we want to apply to another JSON document, so to transform it. So there are a few operations: add, replace, remove, move, copy, and test. This is an example of a JSON patch. So in this case, we have two operations. Each operation is performed in sequence. And if one of the operations fails, the patch is completely aborted. So this is an example. So we have the patch with the two operations that we want to apply on that JSON target document. So the first operation is basically a replace. We use a JSON pointer to specify what we want to replace. So the first object, phones, and then mobile. So we want to replace that mobile phone with that new value. So it works. Then we can move on to the second operation, which is a remove operation. So we want to remove that object. So that would be the final object. Again, keep in mind, it's a new object. So in terms of the API is pretty simple. We have two JSON documents. So we have the target JSON document and the JSON patch. And we just need to define the patch and apply the patch to a specific JSON document. And what we get a return is, again, a new object. We will also have that builder API that basically allows you to dynamically construct your JSON patch. So this is an example. So I have a JSON patch builder, then I can dynamically construct my patch. So the first operation is an add operation. Second one is a remove operation, and then obviously I need to apply the patch. Another standard that will be adopted is a JSON merge patch. That one is, it's not tricky, but so for example, so this is the patch. So this is the source, and this is what you want to achieve. So for example, this is basically a replace. So if you want to replace B by C, you need to basically put the new value there. If you want to do an add, this is what we do here. So you just insert in the patch the new value that you want to add. On the other hand, if you want to remove a key, you just need to set the value of the key to null. There are a few limitations. Typically, if you are using in your original document the actual null value, it won't work. So this is an example how it would work. So this is the original document that we want to transform using that patch, and that would be the final document. So for example, let's look at the title. So the original title is goodbye, but we want to change it to hello. So for example, we don't have the phone number, but we want to add the phone number, so we need to set in the patch the phone number, and so on. It's a fairly basic standard. I mean, it's a 2-page RFC. But it's useful for quite a few use cases, so we think it's a good idea to use it. So we basically have two, This is how it would work for the merge patch operation, so it's exactly the same way. So we have the JSON patch support, and we have the JSON merge patch support. Now, those two patch API can be used in two ways. They can be used to transform a document, but we can also use them to basically get a diff out of two documents. So we use an original document, and we use a target document, and we use the diff method to just get basically a JSON patch that describes the difference between those two documents. Something else that we'll do in JSON P11 is to basically make it SC8 friendly. So we'll introduce specific JSON collectors to do those kind of things. So if you look at that, so we basically get all the cars. We do a filter on just the Audi brands. And what we return at the end, since we are using a JSON collectors, we get a JSON array of the Audi cars. So we are still in the JSON API. So there are other things that will be done around that API. One of the things that is important is JSON Big Data. So the idea is that, for example, you do a query to Facebook services, you get in return a 1 GB JSON document, something that will not fit into memory, but still you want to use it. So we would like to also support those use cases. Having said that, the JSON big data support is something that has just been started, so I can't really share anything regarding that at this day. Something else that we plan to do on the web front is to add SSC support, so server-sent event. SSC, that's a standard that is part of HTML5. It's pretty common. It's widely used. If you take any HTML5 browser, it has support for SSC. Each HTML5 browser has a JavaScript API to use the SSC support and so on. It basically gives a means for the server to push notification to the client. So we have a client, let's say a web browser, that is establishing over HTTP a connection to a server. And at that time, the server has a means to push in an asynchronous way notification to the client. So it's something that is very useful. So we had this question, okay, we want to do SSC in the platform. Where should we standardize that? We could do that in the Servlet API. We could do that in the WebSocket API, because at the end of the day, the WebSocket API has also a means to push payload from the backend to the client. But the WebSocket API is obviously bidirectional. SSC is one way only. We could do that in JAX-RS, or we can even have a standalone JSR just to standardize SSC. That last option seems to be very expensive. So we had a lot of discussion, and at the end it was decided that it would make sense to standardize SSC in the JAX-RS API for different reasons. One of the reasons is that Jersey, the reference implementations, already support SSC in a proprietary way, but that means that we know how it takes to support SSC in a JAX-RS implementation, and it's not that expensive. Another reason is that SSC is often used with REST applications, so it might make sense to support SSC in JAX-RS. So how it will work? So this is basically a JAX-RS and a server endpoint. The only thing that is specific is the produce type. So we are producing a text event stream type. And we have this event output, which is basically an object type that represents a channel to the client. So we set the event output. In this particular case, I'm starting a thread. That's typically something that you won't do in a pure Java E code. This is more pure JAX-RS code. But I need to have a thread, an external thread that is issuing notification in an asynchronous way. So this is my external thread. So everything is done here. So I have this event output, send. So I'm just sending some payload to the connected client. On the client side, this is JAX-RS client API code. So we set a web target to our SSC endpoints. We have this new object event source. That basically represents the connection to the SSC endpoint, and then we just need to register that callback that will be invoked whenever a notification is being pushed. And we shouldn't forget to obviously open the event source. That's where all the heavy lifting of establishing the connection, registering the callback, and so on will be done. And we are done. This is Java code, but obviously the SSC JAX-RS backend with SSC will support JavaScript API, and we think that it will be the most common use case. On the web front, we plan to introduce also a new MVC framework. Now, we already support MVC in Java E. I mean, we have JSF, Java Server Faces. But JSF is a component-based MVC approach, and we would like to provide an alternative to JSF, which is action-based. So that's why we will introduce that new MVC framework. So it's not about replacing JSF. It's really to provide a different approach. So it's about providing more choice. The idea of that action-based MVC framework is really to try to leverage as much as we can what we already have in the platform. So if we can avoid to reinvent something, we'll do that. So for the model, we'll use CDI. Sometimes we want to validate the model. Obviously, we'll use bin validation. For the view, so basically the templating capabilities, we already support in the platform two technologies, Facelet and Java Server Pages. So they will be supported out of the box. Having said that, we understand that some people don't want to use Facelet or JSP. So the specifications define an extension mechanism that can be used to plug external template engine, such as FreeMarker, TimeLeaf, and so on. Now we had some questions around the controller. What should we do for the controller part? Should we invent something, or should we try to leverage something, which might be a better idea? At the end of the day, it was decided that the controller will be based on JAX-RS. So this is basically JAX-RS code, JAX-RS code. So this is a JAX-RS method endpoint. So the add path annotation is borrowed from JAX-RS. The add get annotation is coming from JAX-RS as well. The only thing we do, we are introducing two new annotations. The add controller annotation to specify to the application server that this is an MVC controller. And in this case, we are also using the add view annotation to specify that this controller method, whenever a user is hitting that controller method, it should be sent to that specific view. In this case, this is a facelet view. The add controller annotation can be put at the class level. In that case, all the method will be a controller method, or it can also be put at the method level. And in this case, we are not even using the add view annotation. We are just returning a reference to the view. In this case, this is a GSP view. This is the model. So we haven't invented something new. It's pure CDI as you would do today. This is a CDI named bin. Nothing new there. For the view, again, we haven't invented something. We are just using what's there. So this is a facelet view in this case. So we reference the model from the view using expression language, something which is already in the platform. This is another view. This is a GSP view using EL again. And this is yet another type of view. In this case, this is a free marker view. So JSR 371, it's that new action-based MVC. It's right now in early draft. It has the notion of view engine, as I explained. So out of the box, the spec says that it should support GSP and facelet. But as of today, the first milestone of Ozark, so the reference implementation, already support, well, you see a free marker, velocity, time leaf, and so on. And since last week, we also have support for markdown views. So something else that we would like, that we are doing in the platform is introducing support for HTTP2. And so today we are using HTTP 1.1. HTTP 1.1 was standardized in '99, and there are a lot of issues with that. Head of line blocking, is one of them. So the spec says that the resource needs to be delivered by the server in the order they have been asked by the client. So that means that if for one reason resources can't be delivered by the server, all the subsequent resources will be blocked as well. And clearly, the fundamental issue that we have with HTTP 1.1 is that it's a protocol that has been designed. So first, it's a text-based protocol. It has been designed for very short flow request response and in a burst mode. So basically, you do a request, you do a request, you get a response. You do another request, you get a response. Then you don't do anything for 2 seconds, and you start again. And this is done over TCP. And TCP is a protocol that has been designed for long-lived connections. I mean, opening a TCP connection is an expensive operation, but once it's open, it's almost for free that you can send information. So we have a lot of workarounds to try to solve the HTTP 1.1 issue, asset unlining, domain sharding, and so on. But clearly, we have reached the limit. So HTTP 2 is trying to solve all of that. It's a standard since, I think, 2 weeks. So there are, in fact, 2 standards. There is the HTTP 2 standard itself and HPAC. We deal with header compression. So HTTP 2 is about reducing latency. It addresses the head-of-line blocking, and it introduced a true support for parallelism, something that we don't have with HTTP 1.1. In HTTP 1.1, if we want to have some kind of parallelism, we need to open multiple TCP sockets, which is very expensive. So very shortly, HTTP 2, so everything happened over one single TCP connection. We have the notion of streams. Streams is basically a logical connection between the client and the server. The streams are broken into frames, binary frames. So that means that we can, I think I have an example. So this is a typical request, HTTP 1.1 request today. So it's a post, and then we have the payload. In HTTP 2, the protocol would issue 2 frames. The first one would be header frames, that contain all the HTTP headers, and then a data frame that contain the actual payload. And the nice thing about HTTP2 is that it preserves all the semantics of HTTP that we are using today. So we still have the notion of get, post, put, and so on, HTTP headers, request, response, and so on. The big change is really on the wire. So the stuff that is happening at the network layer. So all the streams are broken into frames, so that means that we can have at the same time multiple frames in both directions. So the frames can be interweaved together. Not only that, we can also apply priority to the frame in a dynamic way. Server push is something else that is provided by HTTP2. So the idea is the following. So client is doing a request. It requests index.html. The server knows that to render that file, those resources will also be needed. So that means that likely the client will also ask very soon those resources, so the style sheet and the JavaScript file. So the server can decide to proactively push those resources to the client. And obviously, at some point in time, it will send the actual data. So those are the main characteristic of HTTP2. If you want to get more information, I have a specific session on HTTP2 tomorrow. Now, from a developer point of view, we think that a lot of those features shouldn't be exposed. And right now, the only features that we will expose is stream prioritization. So basically, having the ability to get the priority information that is attached to a stream and change that, possibly. Server push, that's a big deal. You have a web framework, and it might be a good idea to give the capability to the web framework to push in advance resources that might be needed by the client, and upgrade from HTTP 1.1. So that's something that we will do in the Servlet 4 API. So that was a short overview around the HTML5 web tier front. There are more. I mean, JAX-RS, so I've talked about SSE, but we'll do more. There will be an update on GSF, and so on. So that's it for the first team. Now, I have a colleague, Sean Smith, who used to work on GPA. And when he's doing presentation, he had this habit of talking about something completely different, so that you can relax for 1 or 2 minutes. So I decided to do that. So something completely different. Today, well, 200 years ago, exactly today, we are celebrating, today, we are celebrating the 200 years of the Waterloo battle that took place in Waterloo, which is now part of Belgium. That was a very famous battle. I mean, it has basically shaped what that part of Europe is today. And, that's also a famous battle because Napoleon, who was the French emperor, basically was beaten by the Prussian and the British. So, as I said, Waterloo is in Belgium, so we thought that it would be a good idea to do something to celebrate that. So we decided to issue a €2 coin for that. So we started to mint the coins, but the thing is that there is a law in Europe that says that basically if a country can put a veto on those kind of things. So France was not very happy with that, so they put their veto on that. Nevertheless, in Belgium, we are creative, and we find a loophole in the laws that says that we need to have the agreement if we want to produce a coins, except for coins which have uncommon value. So what we decided to mint a coin with a €2.5 face value. So that was the short breaks. We can now go back to Java. So the next theme is of development. That's something that, as I told you, we have started around Java 5. It's a theme that is a bit tricky to explain because clearly it's a theme that is leaking through all the API. I mean, as soon as an AG is updating an API, it needs to make sure that it tries to simplify that particular API. So at this stage, we have some idea of the things that we would like to do in the platform to simplify Java 8. CDI alignment is a good example. So, for example, we would like GSF to be more closely aligned with CDI, and that work has been started. WebSocket scope is something else that we might want to do today we don't have the notion of WebSocket scope in the platform. So if you want to have a WebSocket scope, you have to create your own custom scopes, which is a bit tricky. So we have a few ideas that we would like to do. Something else that we have started to tackle is trying to look at the MDB models. So in Java 7, we have simplified the GMS API completely, but we haven't touched at all, in fact, the MDB models, so the message-driven bins that are often used. So this is an MDB today. It's a bit verbose. I mean, so we have the MDB that needs to implement the message listener. We have the callback. We are using the @message-driven annotation to specify to the container that this is indeed an MDB. Then we have the activation spec, which is used to configure the resource adapter, in this case, a GMS resource adapters, and so on. So it's a bit verbose, it's a bit old style. We would like to go towards a model which would look like that. So it's basically a POJO, and we are just using one annotation, @GMS listener, to specify that this is, in fact, a GMS listener. So I think the discussion has been started like 2 weeks ago. So it's it's very early, but we would like to simplify that model. We think that that's something that will be useful. Something else, and it would be unfair to talk about simplicity and not mention CDI, because clearly CDI is the backbone technology that allows all the others API to more easily integrate and simplify basically the complete Java EE programming models. So the CDI EG has different things that they would like to do. Java C support, modularity, and so on. So the first one that they would like to do is modularity. So if you look at CDI, it's a very large specification with quite a lot of capabilities. And it's an issue in terms of adoption outside of the Java EE ecosystems. So they would like to address that by basically splitting the specification in at least 2 sub-specifications. And clearly, this is something that they would do to boost the adoption in Java EE typically. Something else that they would need to address is how we can boot a CDI container outside of Java EE. So that's something that is on their list as well. Something else that they would like to do, so asynchronous event. So event is something that is there since the beginning. So we inject an event, we fire an event, and we have an observer that will be invoked whenever that event is fired. What they would like to do is to add some asynchronous capabilities. So it might look like that. So we would have on the event type, we would have a fire async method. And what we get in return would be a completion stage. Event ordering is something else. So we can have one or multiple observers. So right now, there is no way to tell in which order they will be invoked. So they would like to add the capability to define the order in which the observer should be invoked. Now, if you want to learn more, Antoine, which is the CI spec lead, and Jose, which is in the AG, have a session on Friday. So I encourage you to attend that one. Now, pruning is something that we have started around Java EE 5. So it's basically about removing all stuff from the platform. But we don't want to do that in a brutal way. So we have a very well-defined process for removing those old technologies. So we'll continue to work on that front as well. So the last theme I will touch is infrastructure for running in the cloud. We plan to do, as of today, 2 things around that front. The first one is we will have a new Java EE management API, and we have a JSR that will deal with all the security questions. So the first one, Java EE Management 2.0. So if you look today, there is a JSR 77, which is called G2E Management. I think it's at least a 12 or 13, 15-year-ish old JSR. It's a very old JSR. So the idea with that JSR is basically take some of the good idea of that JSR, revamp them in a modern way, and put a REST interface around it so that we can easily manage through REST Java EE containers. Something else, security. So there will be a specific JSR for security. And clearly, this is one of the outcomes of the survey. I mean, security, if you combine all the security features that have been requested in the survey, security is really a big deal. If you look today in the platform, we have security capabilities, but sometimes there are gaps. So that means that we need to use proprietary extension or third-party library and so on. So we want to fill those gaps. So one of the things that we would like to do is authorization using CDI interceptors. So in Java 7, we have introduced a transactional annotation that basically allows you to deal with transactions outside of the AGB container, so on beans. We would like to have the same ID. So this is an example of that in action. So to invoke the transfer fund, I need to be a manager. I can only do that during the office hour, or I need to be a FIFA boss, sorry. Because one of the things that API would like to provide is also to give the ability to have access to the business context of the application. Another example, so to get the salary, I need to be a manager, and that particular salary needs to be one of my direct reports, so I cannot check the salary of anyone. And something else that they would like to do is possibly externalize those rules in some sort of repository, so that they can be stored and consolidated somewhere. So in that JSR, they have way more things that they would like to tackle. So for example, user management. As of today, we don't have a standard way to do user management on Java EE. That's something that they would like to do. The same is true for role mapping and so on. Alex Kozowski, who's the specification lead of that JSR, will give a session just on that JSR on Friday. So I encourage you to check that one as well, because it's really an important JSR. So that was a short overview of what Java EE will be about. So HTML5 web tier enhancements, ease of development, infrastructure for running in the cloud. Something which is key is that Java EE 8 will mandate Java SE 8. So as soon as we touch an API to do an update, well, it would be good if we can use some of the new SE 8 capabilities. It also means that Java EE 8 will not run on Java SE 7. So as of today, we have 11 JSR, which have been started. So that means that we have 11 expert groups that are working at different pace and are producing specification and codes. MVC is already in early draft. CDI is also quite advanced. The early draft is just a matter of days, weeks. JSON-P as well. JSON-P is quite advanced. JSR, the security JSR, they have a lot of discussion, so things are moving in the good directions. But we expect to have more JSR filled over time. I haven't said that all of them will be done, but for example, it might be a good idea to start to look at JCache seriously. I mean, we've tried to have JCache in Java 7, it didn't make it in time, so it might be a good time to now execute on that. Bin validation, they might want to do 2.0. GPA will highly do an update for GPA, and so on. So stay tuned and watch that space, because over time we'll have more JSR around Java 8. So the roadmap, this is the updated roadmap, because we had to update the roadmap 2 weeks ago, because the first roadmap was a little bit too aggressive. So we would like to be final first half of 2017. So that means that we still have plenty of time to execute on that, but we also have plenty of time to get your feedback. So this is really a call to action. You need to help us. Either you feel confident, for example, you have a lot of knowledge around HTTP2, so it might be a good idea that you join the Servlet for EG. Having said that, being involved in EG takes a lot of time. If you don't have that time, I mean, we all have personal life, kids, and so on. Another option is adopt a JSR. So we ask JUGs to adopt a JSR. So JUGs take a JSR and test that JSR. So does the API make sense? Write samples. Try to break the reference implementation, those kind of things. So we still have plenty of time for you to be involved in adopted JSR. And clearly, that's something that we need to make sure that we deliver on Java 8. Now, if you want to learn more about how Java E8 is evolving, you should follow the Aquarium. That's a blog that my colleague Riza and myself maintain, and we try to push news around the Java the server-side Java, and obviously we cover Java E and Java E8. Last but not least, we'll obviously have GlassFish, so the Java E8 reference implementation. It will be open source and so on. I mean, nothing has changed on that front. So if you want to learn more, you should check those sessions. So there is a quickie on adapted JSR. David Blevins is doing a session on some of the things that might change Java E, HTTP2, CDI, and the security GSR. So with that, yes, we have time for question. And okay, yes.
Just wait for it to report. There you go.
Okay. Is MVC introducing more HTTP verbs? So there's a question around MVC. Is MVC introducing more HTTP verbs, or are the verbs being converged into a common package for JAX-B and MVC to use? Basically, we don't introduce any new HTTP verbs. We are just using what JAX-RS is supporting. What does MVC framework offers over what is already available apart from the official implementation? So the MVC framework is basically a standard. So that means that you will have a standard API that you can use on any Java E8 implementation. Now, it doesn't mean that you have to use it. I mean, you can stick to what you are using today, or you can even just use JAX-RS, for example, with Angular on the client side. So it's just about providing more choice and standardized API. Is there work being done to reduce the number of annotations which have duplicate functionality between CDI, GSF, EGB? Yes, there are some works on that front. So trying to reduce some of those annotation is something that is being tackled. How will SSC work with stateless application behind a load balancer? That's a question I can't really answer. There's a specific question on JAX-RS. Any plans for like? No, that one. So Matteo, you should really ask that question on the JAX-RS user list, because I don't have the answer. So I think I've covered all of them. Is there any question in the room?
Yeah, I'm just going to the back.
Yes, at the back.
Yes, wouldn't it be a good idea to separate new functionality from actually adapting Java EE to the new version of the Java language? Because, for example, you can currently not use the entities from the new Java datetime API in JPA. You cannot have a local date or local date time in your JPA entities. And this way, it's going to take more than 3 years before you can actually do that. So maybe.
Well, yeah, you're right. I mean, so today you can already use the new data API of SE8 with GPA, but it's a bit tricky. I mentioned that we will likely do a GPA update, and that's one of the things that we would tackle. So basically adding JSR 3.1.0 support to GPA. But the thing is that we always, once we work on Java E, we always need to specify a minimum version of Java SE so that everybody can be sure that there's that version. I mean, if we don't do that, that would be very tricky to develop the platform. So it has pros and cons.
Okay, any other questions?
Just wondering if you think that the use of annotations is kind of becoming almost unmaintainable. There's so much functionality in annotations at the moment, with the like the is authorized stuff there for making a transfer. I mean, even testing that in a unit test is practically, it's not really possible in a normal JUnit test, whereas if that was actually coded in an AOP interceptor or something, you could actually test it in Java normally, whereas with that, it makes it quite difficult to test the make transfer method.
Yeah, so yeah, yes and no. I mean, so we have to keep in mind that Java EE, so it's a programming model where we are running in a managed environment, a container. So annotation is a great way to specify what the application expects from the container. So it has pro to use annotation, but I mean, you can also use them in a very bad way. So it's more about best practices. How you should develop your code. I mean, we have Antonio who has developed this monster where he's basically he's trying to use all the annotation he can. So he has a monster things that is really what you should avoid to do. So yeah, we are using annotation. So yeah, and sometimes the testing might be more difficult. Yeah. But what would be the alternatives? I mean.
Sorry, what? I didn't hear you.
What would be the alternatives? I mean, having just a pure API that you can more easily test, but it might be more difficult to, it might not be as easy to develop with, so.
Yeah, I suppose just one alternative I would think for the kind of make transfer thing is that you'd separate you'd have the make transfer method just doing its logic as you have there, but then you'd have like an AOP aspect interceptor that
we have interceptors
like that,
yeah, we have.
I suppose it's just whichever fits.
We have interceptors, and this is basically an interceptors as well. This is a CDI. Well, that will be based on CDI. That will be a CDI interceptor. So, yeah.
Thanks.
Any more questions? The screen is red, but we still have 3 minutes. No? Then, if you want to learn more about what will be in Java EE, try to attend one of those sessions. Thanks.